Hello everyone. Okay, so in this video we're still looking at solving log equations, but we're going to be looking at a method called getting the log of both sides. So you might be heard of that before, we'll take the log of both sides. So that's just another method we can use to solve index equations. So it's very handy if I have an index equation like this where I have an unknown in my exponent. And what does taking the log of both sides just mean, right? It just means you just introduce a log to it. Now, we either use our common log, so like log base 10, or ln, so that's log base 10, and remember ln is log base e. So we usually do that by introducing one of these. So what do we do? So I have 2 to the x minus 1 equals 7 to the power of x. And what I do is I just take the log of both sides. So log, this could be ln, either or, both work. Log of 2x minus 1, 2 to the power of x minus 1 equals log 7 to the x. Using rule 3, I take my powers and I bring them down in front. So I have x minus 1 log 2 equals x log 7. So x times log 2 is x log 2 minus 1 times log 2 is minus log 2 is equal to x log 7. Let's gather my x's all to one side. Gather my x's to one side, so I'm going to have x log 2 minus x log 7, and then bring that minus log 2 over to the right, so it's going to be log 2, change the sign. Factor out an x here, I have x log 2 minus log 7 equals log 2. Divide both sides by log 2 minus log 7. You get here x is equal to log 2 all over log 2 minus log 7. And that is a perfectly valid answer. And if it just says round 2 or 3 decimal places, you simply just put that into your calculator. Right, so let's have a look at some index equations now that would be helpful to use log of both sides. So 2006, this is from the paper 1 question 2. So f of x equals 1 minus b to the power of 2x, and g of x equals b to the power of 1 plus 2x. For a positive number b, find the value of x for which f of x equals g of x. So 1 minus b to the 2x equals b to the power of 1 plus 2x. So I need to get my exponent on its own. So what some rules do I know here? So I think I kind of want b to the 2x on its own, I think. So I'm going to leave my left hand side alone for the minute. For my right hand side, I have 1 plus 2 to the x. Well, I know that's going to be equal to b times b to the power of 2x. Then I'm going to bring all my b to the 2x's one side. So I'm going to have 1 equals b times b to the 2x plus b to the 2x. And I'm going to factor out a b to the 2x. 1 equals b. That's right. Factor out b to the 2x. So b to the 2x. Factor it out. That's going to be b plus 1. So divide both sides by b plus 1. 1 over b plus 1 equals b to the 2x. And I want x on its own. So an easy thing for me to do is take the log of both sides. So log of 1 over b plus 1 equals log b2 to the x. And then what we have here is log 1 over b plus 1 equals, take that power, bring it in front, 2x log b. Divide then both sides by 2 log b, because I want to get x on its own here. So 2 log b. So I'm left with log 1 over b plus 1 all over 2 log b is equal to x. And there you go, there is my answer. There. Right. Here we go. So 2011. Question 5. Solve for x, given your answer to two decimal places. So I have 3 to the power of 2x plus 1 minus 17 times 3 to the power of x minus 6. Well, I notice here I can rewrite this first term as 3 times 3 to the 2x minus 17 to the power of 3 to the x minus 6. I can then rewrite this as 3 times 3 to the x squared minus 17, 3 to the x minus 6. I'm going to let 3 to the x equal y. I'm going to have 3 times y squared minus 17y minus 6 equals 0. So 3y squared minus 17y minus 6 equals 0. Solve for y. 3y here, y here. Then I'm going to have here minus 6 plus 1. So I have 3y equals minus 1. Y is equal to minus 1/3. And y is equal to 6. Remember, y is equal to 3 to the 2x. So 3 to the 2x equals minus 1/3. Well, that cannot be true, right? So there is no solution for that one, because no matter the power of x here, it will never give me a negative number. So we could validate that by taking the log of both sides. So if I take log of 3 to x is equal to log of minus 1/3, well, as you see, I can't have that. I can't have the log of minus 1/3, so therefore we can say that is not a solution. And y is equal to 6, so 3 to the 2x is equal to 6. Take the log of both sides. Log 3 to the 2x equals log 6. 2x log 3 equals log 6. X is going to equal to log 6 divided by 2 log 3. And there is my answer there. Right, so first one there is not a solution. So my answer is x is equal to that. Right. There's one more question like that here. So if 2 to the x plus 2 to the power of 1 minus x minus 3 equals 0, solve for x. Well, that's the same as 2 to the x plus 2 divided by 2 to the x minus 3 equals 0. Let y equal 2 to the x. I get y plus 2 over y minus 3 equals 0. Multiply by y, I get y squared plus 2 minus 3y equals 0. Y squared minus 3y plus 2 equals 0. Two numbers that multiply to get 2 but add to get minus 3, minus 2, minus 1. So y is equal to 2, y is equal to 1. I let y equal 2 to the x, so 2 to the x equals 2, x is equal to 1. 2 to the x is equal to 1, but x is going to equal 0. So we actually need to take the log of both sides there. That was a nice, easy question. Then finally, 3 to the x minus 1 equals 5 to the x. So 3 to the x minus 1 equals 5 to the x. Take the log of both sides. Log of 3 to the x minus 1 equals log 5 to the x. X minus 1 log 3 equals x log 5. Multiply in this, x log 3 minus log 3 equals x log of 5. Bring all my x's to one side. X log 3 minus x log 5 equals log 3. Factor in x, I'm left with log 3 minus log 5 equals log 3. X is finally going to equal to log 3 all over log 3 minus log 5. So there you go. Alright, we're going to come across that method a bit more in the later questions, but I just want to introduce the log of both sides methods. And I hope this video was some help to you guys. And I'll catch you guys later. Bye.